Hi, in this video we are going to look at the malformed packet attacks first. That's the second category of single packet attacks. We've already looked at scanning and sweeping attacks, or snooping or sweeping attacks. Now we'll look at the malformed packet attacks. The first type of, or the first malformed packet attack is the SMURF attack. In SMURF attack, the attacker sends a lot of ping requests to the directed broadcast IP addresses, or simply the broadcast IP addresses, which means that the ping packets will reach a specific network and will be sent to all the devices in that network. And the source IP address will be the IP address of the server which the attacker wants to attack. In this case, you can see that one ping packet can result in a large number of ICMP reply packets which are going to be sent to the destination server or to the target server which is being attacked. So all the computers or all the hosts which are sitting in this network are going to be attacking, or are going to be used for attacking this server. In this case, or in case of SMURF attacks, these are acting as zombies. They don't even know, in a way they are acting as zombies, or they are being used for generating the attacks towards this server. If you want to protect your network against the SMURF attacks, you can configure the firewall at the edge of this network, and you can issue the command firewall defense SMURF enable, which means that you are enabling the defense against SMURF attacks. Similarly, another type of attack is the land attack. As you can see that in case of a land attack, the attacker sets the source and destination IP address of TCP packets to the IP address of the victim, which means that it sends traffic, it sends a SYN message or a SYNAC message, it sends a message, sends traffic to this server, to these servers or to one of these servers, whereby the destination IP addresses of the server and even the source IP addresses of the same server. And when this packet reaches the server is going to send a response to itself. So the packet apparently is coming from the same server and is going to the same server. This is a land attack or local network area denial attack, whereby the server is receiving a lot of packets and it's sending the replies to itself. So it's not only receiving the packets, but it's sending the replies to itself as well, which adds even more load to the server. So in order to control this attack, or in order to protect against this attack, what we need to do is that we need to issue the command firewall defend land enable, in which case the firewall sees that if the source and destination IP address are the same, then the firewall is going to discard that packet. Or even if the local loopback IP address is being used as the source IP, even then it is going to discard the packet and add the source to the discard the packet, and it is going to protect the server. The next attack is the Fragment attack. The Fragment attack is similar to the SMURF attack, but in SMURF attack we were using ICMP. However, in Fragment attack we use UDP, and the UDP traffic is generated by the different hosts, and the servers are going to be attacked using the UDP traffic, in which case UDP traffic is sent to a broadcast address, and all the users sitting in that broadcast domain are going to send responses to the server, which is a fake IP address, fake source address, or the IP address of a server, and all the huge UDP traffic is going to go towards the server, and thus the server comes under attack. In order to protect against the Fragment attacks, we configured the command firewall defend Fragment enable. This is going to protect your network. Configuring this command on the firewall is going to protect your network against the Fragment attacks. The next attack that we're going to look at is the IP fragment attack. As you understand, if you understand the IP header or the IP mechanism, IP can be used, or IP protocol can be used for fragmenting the IP packets. IP packets, large IP packets can be fragmented and then they are reassembled at the destination. The different fields that are used for fragmenting and reassembling of traffic include the DF bit or the don't fragment bit, more fragment MF or the more fragment bit, fragment offset and length fields. These are the different fields or the bits that are used during the fragmentation. However, if the fragmentation, these fields are inconsistent, or the information contained in these fields is inconsistent. For example, if don't fragment and more fragment bits are set at the same time, this is an inconsistent combination. So if these fields, the information in these fields is inconsistent with each other, then some of the destinations or some types of devices might not be able to process this information, and they might even crash. Either they would be their performance could be compromised, or in worst case in situations they could actually crash down as well. So in order to avoid this, we can issue the command on the firewall that firewall defend IP fragment enable, which means that we want to protect our network against the IP fragment attacks. The next attack is the IP spoofing attacks. In this case, or in case of IP spoofing attacks, what we are doing is that, what the attacker is doing is that the attacker is using fake IP address to access the resources. This is generally done in order to get unauthorized access to certain resources, because if you have allowed certain IP addresses to access a resource, and if the attacker uses one of those IP addresses to access the resource, then the resource will allow access to the attacker. So the attackers normally use spoofed or fake IP addresses to access the resources. In order to defend against this, we enable the command, or we issue the command firewall defend IP spoofing enable. In this case, the firewall is going to check that if the IP address, if the source IP address exists in its routing table, only then it will allow the traffic to go forward. Otherwise, the traffic is not going to be allowed to access the resources that it is trying to access. So if the traffic coming into the firewall is coming from an interface which is actually associated with the source IP in the routing table, only then the traffic will be allowed to go through. The next type of attack is the ping of death attack. In ping of death attack, what the attacker does is that the attacker sends large sized ICMP packets. The maximum size of an IP packet can be 65,535. So if the attacker sends packets larger than 65,535, those packets most probably would be fragmented, and at the destination, the fragmented packets, when they are going to be reassembled, their total length will be greater than 65,535, and the destination attack is not going to be, or the destination device is not going to be able to reassemble them properly. So once again, the destination or the target device might actually crash because of this vulnerability or because of this ping of death attack. In order to avoid this, what we can do is that once again we can enable the defense against ping of death on our firewall. This will enable the firewall to protect, to reassemble the packets, and then see if the overall length is greater than 65,535, it is going to discard those packets. The next attack that we need to defend against is the TCP flag attacks. As you might be knowing, that there are different flags. There are 6 flags that are available in the TCP header, which include the SYN flag, the ACK flag, the FIN flag, the reset flag, the push, and the urgent flags. These are the different flags which are present in the TCP header. Once again, these flags need to be set in certain order, in certain sequence. There are certain valid combinations of these flags, and then there are certain invalid combinations of these flags. So if an attacker sends an invalid combination of these flags, for example, both SYN and FIN bits are set to 1, both the flags are set to 1, this is an invalid combination. Or if a SYN and reset bit are set to 1, this means this is once again an invalid combination. So if a receiver receives an invalid combination of these flags, then the receiver would get confused, would not be able to process them, and trying to process them would consume a lot of resources, or in certain situations, some of the destination servers or some of the systems might even crash. So in order to defend against these attacks, we can issue the command TCP flag enable, firewall defend TCP flag enable, which is going to defend our systems against the TCP flag based attacks. The next type of attack is the teardrop attack. Teardrop attack, once again, like the ping of death attack, is playing with the fragmentation of the packets, like the IP fragment attacks. It is playing with the fragmentation mechanism in the IP header. The last fragment, the last fragment flag or the fragment offset flag, these flags must be consistent, which means that the total length of the packet and the fragment offset field have to be consistent with each other. If these fields are not consistent, the destination cannot actually reassemble the packets, and it is going to get confused, and once again the system can crash depending upon the sensitivity of the system, of the destination system, or it is going to, or its resources are going to be consumed and its response is going to get slow. So the firewall, if we enable the firewall defend teardrop enable command on the firewall, it is going to check the consistency of the fragmentation information and see that there is no inconsistency, so that when this traffic reaches the server, it is going to be ensured that the server is going to face no problems in trying to reassemble this data. The next type of attack is the when-nuke attack. When-nuke attack is a specific type of attack which targets the NetBIOS port 139. This attack was targeted towards older Windows system like Windows 3.1, Windows 95, or Windows 98 or Windows NT. However, these attacks are, most of the modern or all of the modern Windows systems are not vulnerable to these attacks. Still, if we want to protect our network against these attacks using the firewall, we can configure the command firewall defend when-nuke enable. Once we issue this command, then the firewall is going to check for traffic that is coming for port 139, and it can protect against the attack traffic. These were the different attacks, and we saw how we could defend our network using the firewall, using command line interface or CLI commands. We can also protect our network using the graphic user interface on the firewall. If you want to configure the firewall using GUI against malformed single packet attacks, you can select which type of attack you want to defend your infrastructure against, and the firewall will start defending, or that particular defense mechanism will be enabled on the firewall, just the way we enabled it using the command line interface. So these were the different types of malformed packet attacks and how we can defend against them. In the next video, we are going to look at the special packet attacks and the URPF or Unicast Reverse Path Forwarding feature. So see you in the next video.